Let's try this again. So if you've been paying attention to most of the talks here, we could probably agree that software is pretty amazing. So at lunch, we talked about how we might be able to run Python in our web browsers. There's been talks about great ML stuff we can do. And through most of my life, I've watched software evolve. When I started using computers, websites were almost always white backgrounds, black text, rather boring. And that was seen at the time as state of the art. But we've evolved a lot since then. Most websites, in fact, aren't even singular services anymore. They're multiple sites strung together over protocols and sockets. So I think it's safe to say things have gotten more complicated, along with security, multiple services, and so have our bugs. So part of the problem with scaling software systems is every time we've done that, we've created new modes in which we can fail. Things can go wrong in ways they never went wrong in the earlier days of the internet. But I think it's safe to say this is expected with any sort of evolution, right? Things are going to evolve, they're going to get complicated. So occasionally you'll look at this and you'll get some of these bugs if you've worked on a service that make you think that maybe getting into this whole computer field is a mistake. When you started, it was great, it was ideal, you said hello world, and now you're in these bugs that you spend hours on end trying to figure out some multi-threaded issue. And maybe we don't want to go as far as saying let's just forget computers altogether, but it can be rough. But what if instead of viewing bugs as something negative, as something where we feel bad about them and we beat each other up, we saw this as an opportunity to learn and grow as a team and individuals, provide better for our customers. And so that's what we're going to talk about. So I wanted to start by thanking everyone here for inviting me. I came here from the US. I live in Seattle and work for Google Cloud. Particularly, I work on the client libraries. And it's been really great to visit you all in Toronto. So thank you very much for letting me come here and talk to you a bit. What I have on screen right now is what I believe is likely the first ever computer science software bug. And there's a unique trait about it. It's actually a bug, right? Our bugs today aren't usually insects. In this case, it was a moth that was found in a relay system. I think for most people that have went to a computer science education have heard about this story about the moth in a relay and it causing an issue. But you'll also notice this is a post-mortem as well. There are times and actions that happened, description of what was going on. But here we are. This is the first ever bug. We've been doing this for a while. We've had post-mortems. This isn't a new thing. Now, our bugs, though, they aren't insects anymore. Sometimes they're typos, and sometimes they're things as complicated as a cosmic ray if you start dealing with more complicated computers or things in space, for instance. But the goal hasn't changed. Ultimately, what we want to do is create a system that works better for our customers, that fails less often, and that evolves. In order to kind of think of how we should be working on postmortems and fixing our issues, I wanted to talk about some other industries. Software as a field is relatively young, but we have a lot of industries we can look at that have been around a much longer time. And some of these industries deal quite literally with life and death. Most software practitioners will never have to consider the fact that their software could cause harm to another human. There are exceptions to this, but the majority of us, that's not something on our mind. So the first organization I wanted to speak about is the National Transportation Safety Board. This is a US-based organization that monitors our air travel, shipping vessels, hazardous materials, so things including oil pipelines as well as including commercial aircraft. And there's a story that happened rather recently that most people probably know about. Wasn't a great time, right? Something very bad happened with airplanes and caused a fairly significant loss of life. And for the folks that live in Seattle, this is recognizable and noticeable. We have a lot of aircraft right now parked about 20 miles south of my house because of this incident. And this picture gives you an idea of, it's a bunch of different airlines. But from above, this is one of the lots, and it extends as far as some of the employee parking lots, because they don't have anywhere to go with these planes. And so it's fair to say it's being taken pretty seriously. But what we can do instead of looking at this as a blameful thing and just being sad, we can see this mistake as an opportunity to learn, to never repeat this again, to find ways that we could prevent this from happening again, so we could be more responsible and go further together. And this has worked. The NTSB has had more than 13,000 different safety recommendations over their lifetime for all of these modes of travel, and it has reduced accident rates. And so we found that if we don't just blame people, but instead look at it as a way to prevent and mitigate future disasters, we can get something beneficial to everyone. So what does one of these reports look like? If anyone here has done a postmortem, this will likely look pretty familiar. The beginning of the report has things like dates, where it happened, in certain cases weather. It's something you see a lot more often on the maritime reports because visibility becomes a very important detail. Just sort of ground setting things, right, what's going on. And then you get into the biggest section of the report, which is where you're going to see factual information. When did this happen? How did it happen? Often this will include things like diagrams, especially if we understand how something failed. And the most important thing will come at the end of the report, where they'll start to talk about recommendations. This report is unique because it had 3 different varieties of recommendations. I believe there are 8 total recommendations from this report. Most reports have 2 to 3. And so this accident was really gone over carefully, I think mostly because there were 2 different airline incidents that they saw fit to group together. So how might you do this? There's a really important detail of how the NTSB operates. They can't hold you criminally liable, so they have no prosecutorial authority. In the US, we have other organizations that can do that. We have multiple, in fact, but the NTSB isn't one of them. And the work they do to work with engineers and air traffic controllers and pilots in an incident like this isn't one about associating blame or liability. It's a conversation about how would we have not done this and what actions were taken and what might need to be done around those actions to avoid this happening again. And without that, it's hard to imagine they'd have such success finding mitigations at all, because people have a tendency, when you start to blame them, to shut down. Right? We're not really conditioned to share our faults as humans. We tend to want to hide them. And this happens in our teams as well. So I want to talk about another industry. So this is sort of cheeky. I don't actually want to talk about Mars and Murray's candies. I want to talk about something slightly more grim, and that's the Morbidity and Mortality Conference. So in medicine, as part of the learning and growth of the industry, they hold conferences to discuss typically complicated cases. So anytime you have multiple physicians or organizations working with a patient, there are a lot of opportunities for things to go awry, for information not to get translated, things not to get mentioned, poor assumptions to be made, etc. And so these conferences give a venue in which we can discuss ways to have better patient outcomes, better procedures. But a sort of surprising thing is that the photo that is on the screen doesn't really represent how we tend to do things. And there's a lot of reasons for it. That photo looks really judgy. If you were seated in front, a bunch of people staring at you, it's unlikely that environment is going to make you want to share much of anything. I see that, and I want to say as little as possible and get out of that room. So they realized that if you want to have an education experience, you should have an education setting. And so rather than having an animus situation, you can have one that embraces curiosity at its whole. So this is out of the UK. This is a fairly common environment that you'll see if you look up these conferences and what they end up looking like. And it was the realization that something even as simple as the setting of a postmortem process can change what kind of result you get. So what else can we learn from these? I mentioned some things along the way of what we might be able to learn from other industries as folks working in technology. I would say the biggest thing we can probably learn is that these opportunities are things to be respected. It's not often that you get the opportunity to improve your system and learn a lot about the ways it fails. And I think that's the easiest thing to forget to do. So I brought up earlier the recommendations. That is the most important section of any postmortem. But in a lot of postmortem processes, when you get done, you might find that your AIs are not the most important thing you leave the room with. You might remember why the incident happened in great detail. But did you ever take any actions when you finished? And there are some other things we've learned. There is a process called the fishbone diagram. Sometimes you hear about things like the 5 whys, 5 hows, 5 whats, depending on the organization you're in. There's a bunch of different terminology. But ultimately, they use this in medicine. And they use it to determine patient outcomes and procedures. We use the same process in tech companies that I've worked for, with different names. We don't have patients, we have users typically. It seems a bit weird to call them patients in our field. We don't have medication, but we may have inputs or something we provide to you. So the same process can be used to understand how do we end up at an adverse event. What combinations of patients and people and procedures and medications, together that forms the adverse event. And by understanding that, it lets you understand how do I prevent this or mitigate the same combinations from coming together again. The other thing I think we can learn that I haven't seen embraced as much as things like the fishbone diagram is thinking about who is present in our postmortems. When they surveyed medical practitioners about the morbidity and mortality conferences, they found that about half of participants believed that management of hospitals had no place in the room. It's a similar way I've heard it phrased within software at time is that the people responsible and accountable should be in the room and no one else. And so typically that looks like engineering and maybe management directly of the engineers, sometimes product. But it's unlikely that your CTO would ever need to be in this room. And there's a lot of reasons to consider why that would be. Much like the earlier setting I showed with everyone staring at a person, your CTO is not likely a person you want to share intimate details of how you messed up. Your relationship with them is probably not one of friendliness. You probably only ever see them in these situations, and that animosity isn't going to result in what you want. So we could probably learn something from that more broadly. So enough about sort of broad ideas of what we might be able to do different. I wanted to bring up how you might conduct a postmortem by section. And at the highest level, postmortems can be broken down to 3 steps. We need to think about why something happened, why we're in this incident. We should consider how could this incident have been worse than it was and how it could be better. And we'll talk a bit more of that later. And ultimately, we want to worry about how can this never happen again? Because that's where the value starts to come in. Like I said, I think we all focus on number 1 and we understand that very well, but number 3 is where the value's at. So let's go through an example incident and an example framework. This is pretty similar to the framework I currently use at work. It's simplified a little bit to fit into a talk. So we start with a summary. And at a high level, the incident that I'm going to show you today is one in which the documentation for all the Python libraries for Google Cloud went down. They were offline. And that's all we need to do in the summary. This is likely here, not for your team, but for partner teams, possibly people like CTOs have a rough idea of what happened. It's helpful when indexing, et cetera. Similarly, we'll have a section for the root cause and the triggers for why this occurred. And so in this case, it seems that during the repository cleanup, an engineer on the team had write access to the branch, GH pages. For those of you that use GitHub pages, probably know what this is. It was deleted, and all the pages were gone at 404. And then the user impact more directly from this. Well, for 2 hours, we didn't have our docs. And you'll find that this is about the section that people far away from your team are going to stop reading. This is also typically the level of information you share with customers at first. The rest of this gets a little more personal and about the engineering system, and so it's not usually as relevant to those people. And your internal culture might determine how much you share externally. You're likely going to allow people internally to see this, but it's just unlikely they're interested. So how did we detect it? This example, we detected it via a customer. Someone had filed a bug on a repository saying, hey, I'm noticing that your documentation is 404ing. Do you know why that's happening? And so then at that point, we now know we can go look into it. But I also made a note in here that the delay to the initial report was 30 minutes following the outage. And so for a system, that seems like something we might want to work on, right? 30 minutes is a fairly decent time to have none of your documentation. And in the end, it was resolved by republishing the branch. You'll find a lot of time the resolution is not as interesting as things like the detection and the impact, but it will express how we got back to our state. This is about the point at which I think engineering gets really interested. Once we get to the timeline, we can start to discuss exact things that occurred. So again, this is simplified in the actual report. This is a real issue, by the way. I didn't make this up. There are about a dozen things in here, but for slide reasons, I'm going to simplify it. So the branch was deleted around 9:45 in the morning, and by 10:21, we knew we had an issue because we had seen the issue on GitHub. It was responded to by 45, and by 55, we'd republished. And then an hour later, we had doc serving. So there's another interesting thing, right? There's an hour gap in there, and that we'll probably want to talk about. So this is a section of postmortems that we use at Google that I don't think happens as much externally. It's this concept that we always discuss what went well, right? What was good about this postmortem? Where did things not fall over? They went as expected. Then we have a section where are things bad? And those are areas that are usually relatively straightforward to improve. And then we'll talk about lucky after those. So what went well? Well, for having no trigger for this, we found out pretty fast. I mean, a bug filed within 30 minutes isn't bad. Most of your users aren't going to file an issue and your docs are 404ing. They're going to walk away, maybe angry, maybe they'll come back later. But it's unusual that people file bugs. This is sort of a normal thing to embrace if you work on any repository, is there's a good chance that more than that one person has this problem. They were just nice enough to take the time to file it. So what went poorly? Well, I mean, at the most basic level, that branch probably shouldn't have been deletable at all. There's almost no use case I can imagine, in our workflow anyway, where you'd want to allow someone to delete the GitHub Pages branch. The other problem, which is that hour you saw, is that publishing is not very clear on GitHub. Most people using GitHub Pages have relatively small sites. But for us, this was across about 5 to 6 dozen API surfaces and all of the reference docs. So things had gotten very big. And so publishing this from nothing took a substantial amount of time. But we didn't have a lot of logging. And so it turns out we republished 2 or 3 times. We kept repushing the branch because we thought something had went wrong, when in reality, we just weren't waiting long enough. We were being impatient, and it was an outage. And I'm sure you can all imagine how that might happen. So where you got lucky is one a lot of people don't think about. And it's a little harder to fully describe. And it's going to change on each team, and it does even at Google. It ebbs and flows a bit. But you tend to think about this as what went well that you were not responsible for. In what ways did the stars align so that way you had a not terrible day during this postmortem? And the reason we talk about this is these are the sort of things that you want to protect for all future incidents. If you don't control it, you can't guarantee it'll be there. But if you're lucky enough to observe this, you can make sure it's always there in the future. And so in this case, one of the ways we lucked out, which might be hard to actually reproduce in the future, unfortunately, is that a member of our team had a local copy of the branch handy, so we didn't need to rebuild it. And the reason this is so lucky is while our documentation is generated, there's a small subsection of it at the very top level that isn't. The only place that documentation ever existed was in that branch. And because it was fully deleted and gone, unless someone would have had that copy, we would have had to write that again. We probably could have figured it out. We could have went to the web caches, probably got some archive from GitHub perhaps, but it would have taken us a lot longer. And so this points to having some archival system, for instance, for your repository. And this is arguably, as I said earlier, the most important section of every postmortem, your action items. You spend all this time diving into what went wrong, how it went wrong, the things you might want to protect. But that has virtually no value if you don't take the final step. Make time on your team to fix your issues so you don't end up in this place again. So for this example issue, we would need to protect the GitHub Pages branch. That's the most obvious thing we can do. We can prevent that deletion, this exact scenario, from happening again. But we'd also like to look into, could we do something around the logging for GitHub Pages if we continue to use it? Maybe we won't delete it again, but we're likely to have some issue where maybe the documentation can't be rendered quite right, and having better logging would allow us to quickly debug that in the future. We also realize that on our team, maybe our use of GitHub Pages isn't what it's intended for. Maybe the Googles of the world aren't really meant to be using GitHub Pages. Maybe we should have our own documentation solution, and we should look into that. And so one of our action items is to investigate a new doc host. Ultimately, you can break these things down into a few sections. You're either going to be further investigating after the incident, so diving deeper into one of these action items to see if there are any ways you can improve. You're going to be repairing damage from the incident. Because one of the things we often do in incidents is we make rash decisions to quickly get things back up for customers, and we need to go repair that damage that we created. We also need to find ways to detect the future incidents our service might have, mitigate the future incidents we might have, and if possible, prevent them from happening in the future. I think it's important to remember that when we fail, we do so that we can improve and we can become better. There's a phrase that's rather popular within our community that we should fail fast. I think it has the right idea, but it unfortunately kind of communicates the wrong message. When I hear fail fast, it's easy to interpret that as the expectation is you will fail. I don't think we should expect ourselves to fail, but we should be prepared to. And we should have a culture where when we fail, we're prepared to share and learn from it, not feel beaten up about it. It's also really important to remember that blame doesn't deter people. We blame each other when things go wrong. We do this in our personal lives. We do this in computer engineering, in software systems, pretty much everywhere. And it's just sort of the human emotional response. But it doesn't stop people from failing. It definitely doesn't make people feel good. And I'd argue if you thought about it for a little bit, it probably doesn't make you feel that good either. It doesn't help us grow. It doesn't really help anything. And if we can instead try to think about this rather than responding too emotionally about it, we can grow better as teams. The other really important thing to remember when doing these postmortems is that one of the possible failure modes and things that went wrong is never a human. If you ever find yourself at the end thinking, my coworker made a mistake, you've just missed the opportunity to fix your system. Because at the end of every day, all humans working on a product are part of a broader system, and that system can be corrected. If you try to fix each individual person to do things exactly right, it's not going to scale very well, and it's probably just not going to work. At the end of this, you might think, well, you could just fire the humans, but you're going to find you don't have a team really fast, right? Because everyone makes mistakes. So I wanted to make a fictional example of why we might not blame people. So let's imagine that this GitHub issue is filed on a repository we own. So we implemented a cool new feature in our code that will light your computer on fire. It wasn't documented, but this user caught it, and we appreciate it. And so then a developer assigned it to themselves. Cool. OK, so someone has noticed this on our team. At least we know the incident has been discovered in some way. And the developer fixed it and closed it promptly. In a way, this is good, right? The bug is fixed. No one is going to be having an on-fire computer anymore. But we also have no idea why the computer was on fire. We have no idea how to stop ourselves from ending up in this exact scenario again. And I posit that if you have an environment that blames people, this is about as good as it's going to get. So there's a brief test I can give for how you might understand if you are in a blameless team culture. So the most common way that we tend to refer to things in incidents resembles this statement: a script was run. So this is what's called passive voice. Scripts don't run themselves, right? They don't have the ability to do that. A human being had to be involved at some point in time. Now, we're not going to blame that person, but to disguise that under passive voice isn't really blameless at all. It's oddly blameful. It looks like we're trying to protect the person. We can go slightly further, and we can say that we have an engineer on the team that has done this. This is better, because at least we're acknowledging the fact that someone took some action and something happened. But in a team that's truly blameless, you'll find, and this might seem remarkable for people, that you're very comfortable saying, Chris executed a script that deleted the production database. And this is slightly morphed because I'm definitely the person that deleted the GitHub Pages branch in that example, because I'm the only person on my team that's in the office that early. So it could only have been me. So how might you build this postmortem culture so you can get to that point? The first thing you're going to need to do is consider psychological safety as being very important on your teams. Psychological safety is what we derive most all workplace happiness from. A lot of the feelings around work-life balance aren't really about the time you spend at work or not. It's about this. It's about feeling secure and that you're not going to be embarrassed, that you're trusted on your team and you're able to make impacts. And we've realized this also at Google in our management framework. So a few years ago, it was open source to everyone. It's a program called Rework that describes how to have a good management culture at your company with engineers. And the first thing that we bring up is psychological safety, and that everything else is going to come from that. And until you figure this out, it's not worth spending time on how people can feel that they have clarity in their work or that they can have impact. Another thing you can do is find positive examples. So I picked one of many books. This one is a site reliability engineering book. You'll find that a lot of DevOps communities understand a lot about how to run these processes. This one is rather Google-centric, and there's a big section about how we do the postmortem that closely maps to what I showed. So we've gotten all the way to the end, and someone in this room is thinking something roughly like what's on the screen there, despite me telling you that this happens and we can improve. So I have some ideas for you. If you're in the situation that you think this isn't super relevant and your team is a very high-performing team, the first thing I'd recommend is that you start to increase your SLAs. If you truly are in the place where you're not failing, you likely aren't trying very hard. There's a quote from an economist I like a lot that says that if you haven't missed an airplane flight, you've been spending a lot of extra time in an airport. And that measures to anyone that does statistics work, right? It's unlikely that you don't work on a curve, on an average curve. The other thing you can do is, in general, just raise your own bar and learn to break your stuff. That's a whole separate talk, but if you have time, look into things like chaos monkeys. Also look into running drills on your team about possible failure modes and how you would respond if it did happen. And at the end of everything, just remember that outages are going to happen, and no one on the team wanted them to.